So in this question, we're given this larger square, which has sides of length 7, and a smaller square that is where the side is 5. So what we don't know is how is the square position inside when it's inscribed. So we'll just assume a general position. We'll call this distance x. And so this remaining distance would be 7 minus x. We'll have the same thing here. This would be 7 minus x. And this would be x. So this is from symmetry. And that length is 5. The perimeter divided by 4 of the smaller square. And we can apply the Pythagorean theorem here to find what x is. So that's applying the Pythagorean theorem. And this will give us a quadratic. And minus 14x equal to 25. Combine like terms. And 49 minus 25 is 24. Then divide by 2. And then if you factor this one is easy enough to factor. And so x is 3 or 4. Two possible values. But they will actually give you the same square. Just that the x, if this is say 3, then that becomes 4. So if this is 4, that becomes 3. So it's really the same. So it's actually a 3, 4, 5 triangle. And what we're now looking for is the greatest distance between a vertex of the inner square and the vertex of the outer square. So that's going to be this distance. And this is again a right triangle. That length is 7. This here is 4. So it's a right triangle with sides 4 and 7. We need the hypotenuse. Let me just call that D. And this would be the condition 16 plus 49, which is 65. So that distance is square root of 65. So the answer is D.